study class Honda VSN 23EC1740. Object physics. Derivation of semiconductor. The conductivity of a semiconductor. Conductivity of a semiconductor. Derive the expression of the conductivity of a semiconductor. Electrical conductivity of a semiconductor. Formula derivation. Consider a block of semiconductor of a length L, area cross section A, having number of density of electrons and holes as a Ne. On the flow through it as shown in the figure. The electron current, the whole surface consists of the total current. And the flowing the semiconductor is I equal to IE plus IH. N is the density of the conductor band of the semiconductor. V is the drift velocity. Then electron current is given by IE. Ne equal to AVE. Also whole current IH equal to, the equation 1 becomes IE equal to INE AVE plus ENE AVH. I equal to EA. P is the resistivity of the material of the semiconductor. Then the resistance offered by the semiconductor to the current is given by R equal to PLA. This is the derivation and expression for the conductivity of a semiconductor. This is all the derivation from starting I equal to Ne plus AVD and V equal to Ne plus AVE and IH equal to NH equal to AVH. I equal to Ne plus AVE plus NH equal to AVE. I by A equal to E of Ne plus VE plus NH into VH. As we know that E equal to V by I in a magnitude, R equal to PL by A. Here the mobility and drift velocity by electric field. Drift velocity, so Ne equal to Me and NH equal to MH. Then drift velocity equal to E of Ne Me plus NH MH. This is the derivation and expression of the semiconductor. In the electrical conductivity of a substance, being a conductor, an insulator or a semiconductor, depends purely on the number of free electrons present. More than number of electrons present, more is the conductivity of the material. Complete step by step. The electrical conductivity of semiconductor increases with rise in the temperature. With rise in the temperature, more electrons can jump into the conduction bond by taking energy from increased temperature. From our previous knowledge, we know that the conductivity of material depends on free electron concentration. The concentration of the free electron in a semiconductor is less than the conductors and more than the insulators. Because of this, the conductivity of a semiconductors is immediate level, like conductors are not low as the insulators. The normality of semiconductor is the valence electrons present in the not free as they presented in the conductors. Here the valence electrons are presented as the bonds between two atoms. Germanium and silicon are the very common examples of semiconductors. So the correct option is of A. The electrical conductivity of a semiconductor increases with the temperature. Additional semiconductors are a lot of two types. One is the intrinsic, another is the extrinsic semiconductors. Intrinsic conductors is the undoped semiconductor. Extrinsic conductors doped semiconductor. Extrinsic semiconductor are again of two types. The N-type semiconductor is a P-type semiconductor. In N-type semiconductor, the semiconductor is doped with the pentavalent impurities, and those pentavalent impurities of a group of 15. In a P-type semiconductor, semiconductors are doped with the trivalent impurities. Trivalent impurities are the group of 13 semiconductors like zircon, germanium, etc. Generally of group of 14 is the. This is the graph between silicon and tungsten in a temperature and electrical conductivity. Conductivity in a semiconductor. This is the graph between conductor temperature based on conductors, semiconductors, insulators. Thank you.